Hi, I'm Dr. Karen Agar, and this video is a first look at array lists in Java. Normally, people are first exposed to arrays as their first collection type. So let's think of some of the details about working with arrays. An array stores a collection of items. All of these items would have to have the same type. So, for example, you could store a series of ints together, a series of strings, and so on. Arrays also have indices, so it keeps an ordered list starting at index 0 and going all the way through the length of that array minus 1 for valid indices. And what some people don't think about when they start working with arrays is the fact that arrays have a fixed size. When you set up your array, you're forced to provide a size or a length of that array, and that array size can never change. So looking at a brief array example, here I've created a string array, named it colors, and you can see it has exactly 2 indices. Now this is the shorthand way to declare and initialize an array, but once I've done this, I can never add a third element and I can never delete one of these elements. This array will have the fixed size of 2. Note that I could have also done this exact same thing using the long syntax. In this case, I've done the same thing, created a string array colors, set it equal to a new string of size 2. So this allocates the space for 2 indices here. And then I could manually assign each one of these indices the values. So now that we've kind of looked at the 2 different ways to get information into the array, I want to really focus on the details of arrays. We know that arrays have indices. It keeps our list in order. Again, we have to store this collection all having the same types. I couldn't put an int in here. And most importantly, when comparing arrays versus array lists, I want to point out that arrays do have fixed sizes. No matter which way I chose to initialize my array here, I'm stuck with colors being length 2 forever. So it's important to note that once you're comfortable with arrays, you can start branching out into other collection types. There are other data structures in Java that helps us store a collection of items. ArrayLists that we'll talk about in this video is one of those. So just kind of an overview of an array list. An array list is also going to maintain an ordered list of items. So once I put items in my collection, they're going to stay in that order, similar to arrays. But a good thing about array lists versus arrays is that they do not require the programmer to specify the size. We can dynamically add and remove items to the array list, changing the length as needed. ArrayList is a class in Java, and that class has various methods that help us add and remove and do other things to modify and interact with our list. Just like other classes that we've used in Java, like scanner or random, we do need to import the ArrayList class to be able to use it, and we'll look at that in just a second. Here's a look at the syntax in Java. This line of code sets up an array list that holds a collection of strings. Note I've named it colors, just like in the last array example. But if we take a second to just look at this code, other than these carets with the type in between it here, this follows our normal syntax of creating an object. So class name, object name equals new class name, and open and close parentheses. So we can use the same syntax that we're used to creating scanner objects or random objects or any other objects that we've created. And now we're just going to add in these carets the type that the collection is right after the class name. So now that I have an array list named colors defined, I want to now start adding elements to it. Now the syntax to add elements is different than arrays. We said ArrayList is a class that has a lot of methods in there. And whenever we call methods, we're used to using the object name dot and then the method name. ArrayLists have a method named add. So here I'm going to use my object name, and again, this is the name of my list, colors, and I'm going to say .add and pass it the string. Now, the type here has to match the type of the array list because I'm storing a collection of strings. I can only add strings to the list here. If I wanted to add another color like black, I can perform the same thing here. And now I've got red and black inserted into my array list colors, and red would be at index 0, just like in arrays, and black would be at index 1. Note though that I did not have to specify a size anywhere, unlike arrays where I had to specify we're going to hold 2 strings. That is not the case with ArrayLists, which means that I can continue adding other colors like blue as long as I would like. There are also methods to remove colors, so we can grow and shrink our list as needed. Again, note that ArrayList is a class in Java, and so in order to use these things, we have to import that class into our file. The good thing is, if we've used scanner or random before, it's in the same package. So we're going to import java.util, just like we're used to, and then .ArrayList in order to use these features. I'd like to briefly compare our syntax between creating an array and creating our new array list. Again, note when creating the array, I had to specify the size, and I do not have to do that here with an array list. And then here, when I want to add an item in, I have to tell it the index colors at index 0 equals red. And here, I don't have to specify the index. If I just use the add method and put it in, it's going to put it at the next available index. So red, black, and blue would have indices 0, 1, and 2. So when learning array lists, it's important to note that there are limitations to what types I can put between these carets. You can see here that string was an allowed type, and that is because string is a reference type in Java. Array lists can only hold a collection of reference types. This means that those 8 primitive types in Java are not allowed to be put inside an array list. So again, right here where you would insert the type, if you have something that holds a reference or a memory address under that variable name, then we can use an array list to hold a collection of those items. If I had a class named employee, I could use this syntax to store a collection of employee objects because each of those objects would be an instance of employee holding a reference to where that object is stored in memory. Note that this means we cannot do the following syntax. None of my 8 primitive types, double, int, boolean, char, and so on, can be put between these carets. However, the good news is Java has given us a way that we can, in fact, still store integers, doubles, booleans, and so on in an array list collection. So this is an example of creating an array list of type integer. Notice integer is spelled out with a capitalized I in front. This looks a little different than our int primitive type and is in fact a reference type that acts very similar to our primitive ints. Integer is a class in Java, so imagine public class integer. And this is a special type of class in Java called a wrapper class. Wrapper with a W, like you were to wrap up a gift. And the integer class basically wraps up the primitive type int in a reference type object. So every single primitive type in Java has its own wrapper class. We saw the primitive type int has the wrapper class integer, and notice that typically any reference type starts with a capital letter, like strings, like employee, right? And so all of these primitive type wrapper classes also start with an uppercase letter. So int has the wrapper class integer. A primitive double has its own double wrapper class with a capital D. Similar here, boolean with a capital B. And then for char, we can spell out the whole word character just like we spelled out the whole word integer and capitalize the C. You may have used some of these classes before without knowing what they were. So for example, back when learning about strings, perhaps you had to use some character methods like character.isLetter or character.isLowercase. What you were doing was using methods that belonged in that character class. So here I've only listed 4 of the possible wrapper classes, but note that all 8 primitive types do have their own wrapper class. So these wrapper classes exist for many purposes. They allow us to call methods on primitives like we've seen with character, or use them in collections where a reference type is expected, which is what's useful to us with ArrayList. Now the good news is, when working with wrapper classes, the syntax can be a little unique, but Java has overloaded a lot of different functions so that we can often work with them just like we're used to working with primitive types. So here's an example where I have created an array list of type integer. Note again, I could not put int in there, so I put integer, but I've named it int list. So just like in our previous example, if I wanted to add something onto the list, ArrayList is a class, so we've got methods to use. This is an example of calling my ArrayList object intList and saying I'd like to add the value 100. Now I'm allowed to add 100 because it's an int. Just like in my earlier example, I could add colors like red and black and blue because it held strings. If this had been an ArrayList of type string, this would not be a valid argument to pass in here. So the add method will always add whatever argument this is to the end of the array list. So if this list already had 20 items in it, then this would add the int 100 right at the end at index 20. However, there's an overloaded add method where you can specify both the index and the value. So for example, if you wanted to insert the number 97 at the front of a list, no matter how many elements are already in your array list, I can use the method add and specify at index 0 I want to add the number 97. What this would do is shift or move all elements forward. This is expensive as far as processing power and memory, so you wouldn't want to do this in an array list of 1,000,000 items. Just like I can dynamically add and grow my array list, I can also shrink the size of the array list by removing items. So here's an example of calling the remove method and specifying here what index I want to remove. So this is not the value. Note, I'm not removing the number 0, but whatever is currently at index 0 will be deleted. It will also return the value here, which can be important if you wanted to, let's say, print something to the console that said, I just removed number, and then this method call would return that number in your print line statement. So this deletes and returns the element in index 0, and then all of the rest of the elements which previously started at index 1 would all be shifted over. So all of their indices would decrement by 1. The set method allows us to set the value at a given index. So in this example, intlist.set passes in the arguments 2 and 75 and instructs Java to set index 2 to the value of 75. Note that if there was already another number in there, this would overwrite any existing values. ArrayLists also have a method named size. This is very similar to the length method for the string class and returns how many elements are currently in the list. So if you were to be iterating through a list, just like you used to do with arrays, maybe saying while I is less than the array dot length, now you can say while I is less than my array list dot size. There's a get function which allows us to get elements out of the array list. So here I've got an example where I'm saying intlist.get2. Note that this does not get the value 2, but gets the value that's located at index 2. So if the number 500 was stored there, that would be returned in this method call. Other methods include isEmpty, which returns true or false, whether or not the array list contains any elements. And then index of, which if I give it a value, will return the index of that value in the array list if it exists, returning -1 otherwise. This is almost identical to the index of method in the string class. Here's a quick example just looking at some sample code. So again, I've made an array list of type integer so I can add ints to the list. I've named it exam grade, and then I've added two different numbers to the list. 100 would be at index 0 and 95 would be at index 1. I've written an example that loops through this array list. It's very similar to how you've probably written loops with arrays before. So I've set up a for loop starting an int variable I at the number 0. I'm going to increment I every time, and I'd like to continue iterating while I has a value less than my array list, which is called examgrades.size. So in this case, my array list has a size of 2. It's got 2 elements in there, just like an array would have a length of 2. And so the valid indices in this array list are 0 and 1. This for loop is set up to iterate when I equals 0, when I equals 1, and then stop when I becomes 2, the size of the array list. So when I is 0 and 1, we're going to get inside this for loop and print out each element of the array list. Note that the syntax for accessing that element is different than working with arrays. I no longer use those square brackets. I now say exam grades dot, because I'm calling methods with array list, get I. And so the get method will access whatever element is at index I, returning that here. The first time it would grab 100 and print it out, the next time grabbing 95 and print it out. Note that the enhanced for loop also works with array lists and any of the other collection types. This is not the complete list of all of the methods inside of the ArrayList class. You can look at the Java API to see all of the current methods and how to use them. However, this is a list of some of the methods that I find most important for getting started with array lists.